Ever tried organizing a mountain of paperwork? Imagine turning a 100-page legal document, a financial report, or a dense academic paper into a clean, easy-to-read table. That's the challenge AI models face, and it's tougher than it sounds. Today, we're diving into a breakthrough called AOE, or Arranged and Organized Extraction, which is pushing AI to master this messy but critical task. Let's break it down. Here's the problem. Even the smartest AI models today can generate text that sounds impressive, but hides the real work. Think of it like a student who writes a perfect essay, but can't answer the actual questions on the test. When it comes to extracting facts from complex documents, many models produce tables that look structured but are riddled with errors. That's where AOE steps in. AOE isn't just a test. It's a puzzle designed to see if AI can understand and organize information like humans do. Imagine you're a researcher tracking citations in a paper, or a financial analyst comparing companies. AOE forces models to do more than find keywords. They have to reason about the data. For example, in legal documents, an AI might need to link a case's facts to the exact law it violates. In financial reports, it has to calculate growth rates or spot trends, without just copying numbers from the text. So how does AOE work? It breaks down into three key components. First, document preprocessing, cleaning up messy texts, like removing irrelevant details. Then, domain-specific annotation. Humans label data to teach models what to look for, like debt-to-equity ratios or legal statutes. Finally, task-wise instance construction, building real-world scenarios so models can practice before being tested. It's like training for a complex exam. But how do they know if AI is actually getting it right? AOE uses three metrics. 1. CSV Parsability. Does the output even look like a table? 2. LLM Score. Other AI models act as judges, rating accuracy and structure. 3. Cell F1. A detailed check comparing every data point to the correct answer. The results? Even top models like GPT-4 or Gemini struggle. One model had a 97% formatting score but near zero accuracy for real numbers. It's like building a house of cards, perfectly structured but one wrong move and it collapses. Smaller models fared worse, and techniques like chain of thought, a step-by-step reasoning tool, or RAG, which pulls in real data, didn't always help. In some cases, they made things worse. Let's look at real-world examples to see why this matters. Take a CA0, citation context extraction. Here, each row in a table represents a link between two research papers. If paper A cites paper B, the AI needs to pull the exact text from paper B that's being referenced. But here's the twist. Some tasks structure data differently. In financial analysis, like Fin 0, Fin 3, every row usually ties to a single company's annual report. So one document, like a 2022 report, gives you one row of data. But when comparing companies, say Fin 4, Fin 6, each row becomes a different company. If you're analyzing three firms, you'll get three rows, each showing their financials for the same period. Then there's the legal world. For Legal 1, defendant verdict extraction, a single court case with multiple defendants could generate multiple rows. Each row would detail the verdict for one person, ensuring no one's outcome gets lost in the mix. It's like organizing a library. Every entry needs to be precise. But how do researchers evaluate if AI gets this right? Let's look at a specific example. A model was asked to extract citation content from academic papers. The goal? Identify which papers cite each other and pull out the exact text being referenced. But here's the catch. The model got most of it wrong. Instead of pulling quotes from the cited paper, it grabbed text from the referencing one. Think of it like a librarian handing you the wrong book to find an answer. Frustrating, right? Why did this happen? Two key issues: intent understanding and schema construction. The model recognized the task but missed the core requirement, extracting the right content. Plus, it used a table format, but the gold standard was CSV, a more precise format for data analysis. Now, let's look at a financial report task. Here, the model did much better. It pulled key metrics like revenue and profit, organizing them by year to spot trends. But it missed some critical data, like the debt-to-equity ratio, essential for assessing a company's financial health. It's like measuring a room's length but forgetting the width, useful but incomplete. These evaluations aren't just about grading AI. They reveal how closely models align with human expectations. A high score on format compliance matters, because messy data is hard to work with. A low score on content accuracy means the model might give you the wrong answer, even if it looks correct. So next time you see an AI generate a report or analyze data, remember, it's not just about getting some information right. It's about exactly what's needed, in the right structure every time. Because in research, business, or everyday life, the details make all the difference. Ever tried organizing data from different sources? The chaos of inconsistent formats, ambiguous terminology, and hidden context is what AOE aims to solve. By forcing AI to think like a human, reasoning, structuring, and validating, researchers are paving the way for systems that can handle the messy, real-world complexity of knowledge. Whether it's legal documents, financial reports, or academic citations, the future of AI depends on getting the details just right.